Hello everyone, myself K.Priyadharshini, Assistant Professor, Dept. of Information Technology. The topic today we are going to see is r-1's complement and r's complement in digital computer architecture. Before moving on to this topic, we have to see a small glance on number system. So a number system is defined as the system of writing to express numbers. It's a system of writing to express numbers. The types of number systems there are 4 types of number system. We all may be familiar about that. The one is the decimal number system, and another one, next one is the binary, then octal and hexadecimal. Okay, so in decimal number system, we use the numbers 0 to 9. So the base of that number is 10. So how we are calculating the base of the number? So the base of the number is calculated by the usage of digits. How many digits are using in that number system? Okay. So by using that, we are calculating the base of the number system. For the decimal number system, the base is 10 because we are using the numbers 0 through 9. And for the binary number system, the base is 2 because we are using only two digits, that is 0 and 1. So therefore, the base of the binary number system is 2. Then the base of the octal number system is 8. Here we are using the numbers from 0 through 7. So there are 7 digits in that number system. Therefore, the octal number system base is 7. And for hexadecimal number system, the base is 16. So in hexadecimal number system, we are using the digits 0 through 9 and the alphabets A to F. So totally 16 digits are used. Therefore, the base of that number system is 16. Now we move on to the r-1's complement and r's complement. Okay, we all may be familiar about 1's complement and 2's complement. 1's complement is nothing but we will convert all the zeros to 1's and 1's to zeros. That is called as 1's complement. And the 2's complement is nothing but we will just add 1 to the 1's complement. Then we will get the 2's complement. So now we are going to see about r-1's complement and r's complement. So we have already known about the number system and the types of number system, and also we know about the base of that number system. The base may be represented as radix also. So the short form of radix is r. Okay. For a number system that have its base or radix as r, we can define 2 types of complement for that corresponding number system. The 2 types of complements are r-1's complement and r's complement. So the base of the number system is represented as base or else radix. The short form of radix is r. r-1's complement. To find r-1's complement, we have to subtract each digit of the number from the largest number in that number system. For example, if we take the octal number system. Okay, so the octal number system, the base or radix, the radix of that number system is 8 and the largest number in that number system is 7. Because we are using the digits from 0 to 7. Therefore, 7 is the largest number in that radix 8 number system. Okay. So, to calculate the r-1's complement, we have to subtract each digit of the number from the largest number of that number system. If we take 3-digit number, then we have to subtract that number from 777. Okay, so the r-1's complement of a number in any number system with base r can be found out by subtracting every single digit of a number by r-1. So r-1 is nothing but the base is 8 means 8 minus 1. That is called as r-1. So next, the binary number system, the base is 2. Then we have to obtain the r-1. So r-1 is 2 minus 1. Therefore, 1. 1 is the largest number in that number system. To find the 1's complement of 001. So the r-1's complement, r-1 here is 1's complement because r-1 value is 1. So 1's complement of 001. So we can be calculated by subtracting 00 from 1 from 111. Okay, wow. So nothing but, so we are going to calculate the 1's complement of 001. 1's complement is nothing but r-1. r-1 is 2 minus 1. So to calculate the r-1's complement, we have to subtract each digit of that number from 111. Here we are having 3 digits. So therefore each digit is subtracted from 1, 1, 1. So hence we obtain the result 1, 1, 0. Therefore the r minus 1's complement of 0, 0, 1 is 1, 1, 0. So next, similarly in the octal number system, we all know that the base is 8. So its 8 minus 1 is equal to 7's complement can be calculated by subtracting each bit by 7. So 7's complement of 345 in octal number system can be calculated by subtracting 345 from 777. Okay, so we obtain the result of 432. 432 is the r minus 1's complement of 345. So you may think that only we can calculate 3-digit numbers. So how many numbers are there? We have to subtract each digit of that number from the corresponding numbers. For example, if we have 4-digit means we have to subtract the 4-digit from 47. That is, so we have to subtract each bit of that number from 777. So hence the r minus 1's complement of 345 is 432. So next, I think we all may familiar about r minus 1's complement. Now we are going to move on to r's complement. So r's complement is very simple. So the r's complement is just add 1 to the r minus 1's complement. We are going to add a single 1 to the r minus 1's complement. First we have to find the r minus 1's complement for the corresponding number system and then add the value of 1 to that number system. We will get r minus 1's complement. The r's complement of a non-zero number in any number system with base r can be calculated by adding 1 to the least significant bit of its r minus 1's complement. The least, we all know about least significant bit. So in the last bit we have to add 1. So we should not add 1 to each bit of the number. We just add 1 to the least significant bits of its r's complement. That is the last bit of the r's complement. We have to add 1 to the least significant bit of r minus 1's complement. Then we will get the r's complement. So in binary number system, r's complement of 001 can be calculated by adding 1 to the last significant bit of r minus 1's complement. So therefore we have to first find out the r minus 1's complement value. So the example we have already seen first. That example is only we have taken now. So 111 we have to subtract 001 from 111. So we will get the answer 110. So to find the r's complement, now we have to add 1 to that corresponding number. So 110 plus 1 is equal to 111. So this is the r's complement of 001. So the r's complement of 001 is 110. So this is r's complement. So finally we will see one glance. So r minus 1's complement is nothing but we are going to subtract each digit of the number from the largest number in that number system. For example, if it is a base 8 number means we have to subtract it from 7. If it is base 10 means we have to subtract that number from base 9. If it is a binary number system means we have to subtract it from 1. So r is the base of that number. The base is represented as radix. So radix minus 1 value we have to subtract each digit from that number. For calculating r's complement, we will just add 1 to the r's minus 1's complement. So we will add 1 to the least significant bit and not to all the bits. Okay. So that's all about r minus 1's complement and r's complement. Thank you.